Okay, hello everyone. Thank you for joining. My name is Arnon Dagan. I'm a data scientist here at Apiro. I have many years of data science, starting from the good old days of the classical machine learning, such as logistic regression, decision trees, and XGBoost, and others. Then I came through the deep learning revolution, which was quite nice. I worked with CNN, RNNs, and variation of those algorithms. And now I'm very excited that we are in a new era of the LLMs. It has many challenges and many opportunities. So what I'm going to talk today is regarding, not regarding DeepSeek R1, which is a very fascinating talk, but not for now. But I'm going to talk about how we are dealing with LLMs in Apiro and how we have a project which uses LLMs to improve our product. The talk is regarding risk detection at design stage. So what's the agenda? First of all, I'm going to tell you what risk detection in design phase is so that you can follow the talk. Then I'll tell you the challenges of this task. And after that, I'm going to tell you regarding how we try to solve it using LLMs, and also I'm going to talk about the challenges which we have when deploying LLMs and how we solve those issues. So as you may all know, this is a basic software development lifecycle. Starting from planning, then comes the design. After that, there is a code and test where the main development cycle is. And then is the deployment and the maintenance, like the production stage. And the thing is that risks may occur in any stage. For example, if you have a secret in your code, like you have a database and the password is inserted inside the code. If you find this risk in production, like in the phase where your software is deployed or maintained, then this risk is very, very, it can cause many issues, and it's very expensive also to change it. So it's better to do it in when you develop, when you code, or when you test your code. But it's even better if you find it in the design phase. So then it's cheaper to fix this issue. So what is our mission in this project? The mission is to proactively identify risk at the design phase before the code is even written. And also to give actionable countermeasures for it. So what is, how do you know, how do you handle this thing, like the design risk? You need to know regarding a threat modeling process. Threat modeling process is if you have a design like a Jira ticket or a design document, then the first thing you need to do is to define what you're trying to protect, like if you have PIIs in your code or something like that. Then after that, you usually what you do, if you're a threat modeler, you draw a diagram which uses all the components and how they interact between them. After that, you identify the threats. And this phase is very important. And then you go to prioritize of threats, and then you start and think about how you're going to solve it in the mitigation phase. And then you update the design. This is all this thing is done in design phase, and the goal is that when you have a design, you know what are the risks you are going to have, and how you are going to solve those risks before even you write even one line of code. So what is the issue with this process? Well, it's very expensive. And also, as Gartner showed here, the pace of coding is getting higher and higher, while the security review pace is not getting as high as the coding, and there is a speed mismatch. So because the threat modeling process is quite long, it takes a lot of time. You need experts of security, and also they need to know regarding the application which you are developing. So it's a very, very hard task, and this is what we try to solve in Apiro. So our solution, what it does is we use LLMs to solve this issue. First of all, there is a design which comes from the customer. We edit things from Apiro, and then we give it to our first LLM. Our first LLM, we use a Phi LLM. I'm not sure if you're all familiar. It's an LLM developed by Microsoft, and we fine-tune it to the task of classifying if this is a risky ticket or not. After this LLM goes,
simply is it for binary?
I'll answer when we finish the talk. After the classification phase, we use another LLM. We use Orca, which is also from Microsoft. It's better for generating text. So we use it, first of all, to understand the risk. And after we understand the risk, we also use it for mitigation. I'll show you an example, and then it will be clearer what we do. So here is the example. This is a risk. This is a Jira ticket, which is regarding automated customer support chatbot. This ticket, as I said, first goes through our classifier. The classifier found it risky. As you can see, the date where the ticket, I'm not sure you can see, but the date where the ticket was created and the date where our classifier found it is the same date, so it's immediately. And what else you can see, there is also a confidence. Here it's very confident that this is a risk. So that's the first classifier. After identifying that this is a risky ticket, there is a second, the second LLM goes, the Orca, which generated text. The first thing is understanding. What it does, it first finds which category is related to this ticket, in this case, Gen AI usage, and also it writes a description regarding this ticket, implementing a Gen AI chatbot with access to sensitive information, etc. So for each ticket, it writes its own description. And after that, there is a phase of mitigation. In mitigation, there are two steps. First one is it writes a security questions for this ticket. And the second phase, it writes also a threat story. Threat stories, we use Stride in this case, and it writes for each story, the story, and also how to mitigate the impact and how to mitigate it. As you can see, it's a structured output. We use LLM and we add the structured output here. So what I would like to continue at the talk is regarding which challenges we have when deploying those LLMs. So I'm going to talk about 4 challenges. We had more, but I'm going to focus on them. The first challenge, as you can see in the previous slide, the output is structured. So I'm not sure how many of you are using LLMs, but to create structured output is quite a difficult task. Sometimes it fails, and you need to do work to make it better. I found that Outlines is a very, very good framework for this work. What it does, it takes the schema of the output of your LLM, what you write in for the LLM to generate, and it transforms it to regex, and then this regex is transformed to a state machine, and it uses the state machine to improve the performance of the JSON or structured output. So this is one thing. Another thing is effective GPU utilization. We use VLLM. It helps us to utilize the GPUs in all our machines. It has like good optimizations, which uses, I saw like almost all the GPU utilizations. So this is this. And regarding evaluation generated text, this will be in the next slide, so I won't talk about it now. And the last thing is distributed model. We use ArrayServe. This is a very famous framework, which also Google has integration to it and other companies. And it helps us to distribute it in production. This is mainly for the array. It's how a basic design of our system. We have like, for example, here 2 customers. Each of the customer has its own tickets. The tickets are sent first to the fee model, which was fine-tuned to our task. The fee model tells us if this ticket is risky or not. If the ticket is risky, then the other model is used, the Orca, to generate text per ticket per customer. And so Array, what it helps us is it has like also good monitoring for our GPUs. It has auto-scale capabilities, and it also supports Kubernetes, which we use. And now to the main thing I would like to say regarding our challenges is evaluating generated text. Well, evaluation is quite a very important thing when you're talking about data science. And evaluating generated text is a hard task, because if you're looking at the classical way people use to evaluate text, they usually use statistical methods such as Blau, RAG, and Meteor, which basically what they do is they have an input, they have an expected output, and then they compare what your LLM generates against the expected output, and find how many n-grams are similar or not similar. But those methods are not so good anymore. They have many disadvantages. So came, first of all, BERT score was one of the other kind of methods which improved the evaluation. What they did there is they used the embeddings of the expected output against the embeddings of the generated text, and then the similarity was a fuzzy similarity, like a cosine similarity between the embeddings. And also there was a mover score, which did also use the embeddings, but did another function which improved also this evaluation. But that was also not good enough. So there came what I think currently is main methods to evaluate LLMs, which are the large language models as a judge. Those methods are very are more like human judges. That's their purpose. Like to think that an LLM can evaluate other LLMs, so it will be like a human. I'll talk regarding geval. This was a metric which Microsoft published in a paper, and what it's about is they use a chain of thoughts to evaluate the generated output. And what's nice about it, I'll show it in the next slides, is that now you can use different kind of metrics to evaluate your LLM, like hallucination, like consistency, and I'll show you some examples. So first of all, to the classical way that measures LLMs, generated text, Blau score was a very popular way to do it, and it uses basically n-gram precision. They use the geometric mean of n-gram precision, and it was multiplied by the Beverty score. So it's basically based on the n-grams similarity. And now, as I said, I'm going to talk about geval. Geval, I'm using deep eval framework, but it's only a concept geval, so you can use others. The basic concept is you give it an input and then an output, and you can also give it an expected output. It depends on the metric you define. And you can also give, I didn't talk about it, but you can also give a RAG context to this metrics. And then there is you give all this stuff to the LLM which evaluates. The LLM, what it does two things. You define the metric itself by the steps you would like to do. And then it gives, first of all, a score. And what I like about also this framework, it gives you a reason why this score is right or wrong. And you can also add a threshold so that metrics will pass or fail. So to see some examples, here, as you can see, there is a metric I call the consistency. You can call it as you like. I'm using here GPT-4 Turbo, but you can use others. And I define the threshold of 0.8. And now I define the evaluation steps, verify the details remain consistent throughout the text, and then penalize contradictions in descriptions or any sudden change in the estimated facts, and check if character or place names are used consistently. And the last thing is I told which is the evaluation parameters. In this case, I would like only to evaluate the actual outputs. As you can see, what's nice about it, sometimes you don't need the expected output, but you can also define which output you would like to evaluate. And another example is non-triviality, is another metric I defined. As you can see, I also told them all the steps they need to go through. And I also defined the evaluation params. Here, as you can see, I defined the actual output, but I would like also to consider the inputs, because non-triviality depends on what you give in as an input to know the output. And here you can see an example of the generated, evaluated generated text. Here you can see, I'm not sure you can see, but there are 4 different metrics which I used. 3 of them passed, and only 1 of them didn't pass, in this case, non-triviality. Now I'll deep dive to the one which didn't pass, so you can see it clearly. So here the input for this LLM was set up log transition to Spark for monitoring on our VM, and the task was to say why it's risky. What the LLM output was, the LLM output is what you need to evaluate. So this was the VM exposure to the internet creates a risk of unauthorized access and tampering with the log data. Then I give all this stuff to the evaluator. In this case, I gave it to the metric called the non-triviality, which you saw the definition before. And as you can see, the score is low, it's 0.282. And what's nice is it also gives a reason. The reason does not contain details or specific information related to the actual content of the input, JIRA ticket, and so on, and also locks reference to the contained elements and missing relevant examples. So if you use this, what's nice about it is that you can do error analysis quite nice. You can see, if you see like errors, you can know why it was an error. I also recommend maybe to try and use more than one LLM to evaluate your stuff, because so that it won't be biased to a specific LLM. And then you can average the scores or play with them, and also see different reasons why each LLM thinks it's good or not good. And what's nice about it, you can use it for like as a regression test. If you would like to replace prompts, then you can see how it goes, if it goes well or not. Or also another use case is maybe even to use some of it in production to see what your models generates, and maybe if it's not good enough, then to do a flow that filters those out, or generate another text which is better, or give it's a feedback that you can use also in production. And that's it. Okay, so I think like the evaluation, what's very important is that if the old evaluation was very, very strict to similarity, here it's more like a human evaluation, because you can look at the text from different perspectives. And to sum up like the project, currently this feature is in beta. It has 6 customers. We are analyzing about 8 tickets per hour, detecting 1% as risky. And we, as I showed you, we automatically generate contextual threats, model, and security review questions. And the key takeaways that I think that you can take from this talk, first of all, we are in an exciting era where LLMs can deal with very complex problems and solve them at scale. And another thing I would like you to take is the challenges which we have in LLMs. I haven't listed all the challenges because there are more, like how to use RAG and if to use open source or closed source. There are many other issues which I didn't talk regarding context. But here I showed you regarding inference some tips which we use to improve the inference time, and also regarding evaluation, that the evaluation now is more like evaluation of text is more like a human evaluation. It's not exactly, but it comes near human evaluation. That's all. Yeah. Thank you. Now, if you have questions.
Yes. I have a question. You were talking about evaluating the output basically from the LLM. But for example, when you're taking Jira ticket as a source, how much can you trust what's written? Maybe it's not written like, maybe you cannot trust exactly the source. So are you also thinking about a way to evaluate the data source that you're taking? And whether or not you want to actually add, I don't know, like another data source to kind of complement this data? Do you think about that? And is it part of your plan?
I think what do
Repeat the question so they would hear.
okay, I'll repeat the question. What I understand from your question is if we would like to add another data source to the
Yeah, and how much can you trust Jira
Jira
data
tickets?
source, for example? Yeah.
Actually, what we do, we take the Jira tickets. This is our input. Yeah, it's as you know, sometimes it's not so clean. But this is our data. We use it for that case. For this reason, we do it in two phases, because we saw that if you are doing it directed to an LLM and try to generate text, then you have many issues. We first filter, the classifier is trained more regarding, is it risky, yes or no? If it's risky, usually it's risky and it's cleaner. And yes, maybe it's a good thing to try and clean the data before doing it. Another thing is to generate a golden set with expected output and to compare the output with the expected output. Yes, more? Yeah.
Can you explain a little how G-value gives a floating point score?
The score, yeah.
How you get a floating point score? The reason is clear LLMs can blabber about anything, but how you get the floating point score?
Yeah, well, this is quite a complex issue. I'm not sure it's for the talk, but if you would like more details, like the paper has, it's basically goes through the confidence of the output, of the generated output. For example, I signed the paper. They use they have like 5 different scores, and they ran it a couple of times. Then they did the distribution, and this is why they got the scores. But for more details, you need to go to the paper. Yeah.
Are the scores consistent? Like, if you ask it the same, if you give it the exact same input, it will produce the same score every time?
As I think many of you, I need to go. Okay. I repeat the questions. I ask if the scores are consistent. As you may all know, LLMs are not so consistent. So what I usually do when I work with LLMs, I run it a couple of times, and then I average or find if there are scores that are like very different from what I'm expecting. But yes, that's quite an issue regarding the scores also.
What do you actually do when you get a low score with respect to one of the metrics you define? Do you have a few metrics, and how do you actually handle that case?
Okay, I'll repeat the questions. If I have like more than one metrics and like some of the metrics are, I have like low scores, and in others I have high scores. That's what you're asking about. So how do you handle it? So yes, that's also an open question, I think. It depends on what we define as, we can define like threshold per metrics, and then average the results per metrics and see if we are inside the thresholds. And also what I'm saying is we are also looking at the reason, which I said, to see if we have like a consistent error, which we see, then we try to improve our prompts or whatever we would like to do.
Yes.
You said that your your system is consists from two stages: classification and generating text. And there will be definitely a false positive when the task wasn't haven't any backdoors, but your system detects as that's a positive. What did you take it into account of the second stage when you align LLM for generating text?
I'm not sure I understood. You say if we, in the first phase, we have like the false positives? That's what you're asking?
Yes.
Okay, yeah, I understand what you're saying. Okay, I'll tell more details about the second phase, which things I didn't show here, but as you all know, sometimes there are false positives in if the classifier is not perfect, yeah, and usually it's not. So yeah, we have false positives, and what we are doing in our case, we also ask the second LLM to try and to fix the first LLM, because there are also different LLMs, and we use this to improve also our accuracy. Yes, it's a good point.
So I think I'll stop.
Thank you.